Well, hello, friends. Today we're going to do the alarm syscall, which I found when I was browsing through the POSIX spec. It's not something I've ever used, but it seems useful, so let's implement it. So basically, what you do is that you call alarm, and you tell them, hey, wake me up in 5 seconds. And then 5 seconds later, whatever you're doing, you will get a SIG alarm signal, and then you have a chance to react so that you can break out of whatever you were doing. So the first thing we're going to do is make a little test program for that. So let's call it like Al. And let me just refresh my creator so we can get here. And we will do something like, oh wait, where did we get it from? Yeah, UniSTD, okay. Char-v, whatever. And then we'll do alarm. Wait, what does it return? If there was a previous alarm, then it will return the non-zero value, that is the number of seconds until the previous request would have generated a SIG alarm. Okay. Well, we don't care about that right now. So let's just say alarm in 3. And then we will go into an infinite loop. Maybe we'll say something like entering infinite loop. And then I guess we'll never get here, but or I mean, we could actually even do it kind of in a different way. So hold on, let's do it this way. And we'll have a volatile got alarm boolean, and then we'll do signal sig alarm. Can we do this? Got alarm true, and we'll say while got alarm. We have to do that, but that's not going to compile. Oh, right, yeah, because I can't capture. So we'll just do it this way. Can't capture and pass us a function pointer, but we can do this. Okay. And I don't have printf. Okay. So let's say in 2 seconds, and then we'll just verify that this thing actually does what I think it will. So we'll try it out on Linux first. Yeah, so it exits, right, and then we'll print printf. Oh, we got the alarm exiting. Cool. Right. I think we're good with that. And then let's see if we have alarm already. So it calls sc alarm. So it seems like I've been poking at this a little bit in the past, but how far does it actually go? Sys alarm. Yeah, that's what I figured. So we get all the way to the process class implementation of the alarm syscall, but then we just assert that we're not here. So I think I added this a long time ago when I was trying to make some third-party program work. Yeah, so, but that's good for us because it means that we don't have to do all of the syscall setup boilerplate. We can just go right here. Okay. So what we're going to do with this is that we are going to set a sort of a deadline, I guess, for it. So we'll do something like, oh wait, hold on. If seconds is 0, then we should cancel any pending alarm request. Okay, and then we'll say seconds is 0, then as alarm is false. Return, I guess we should return whatever the previous alarm, how much time was left. Let's say fix me for that one. return number of seconds left until alarm would have fired. Right, and then we'll say m has alarm true. M alarm deadline is guess that would be the G uptime plus seconds times ticks per second. And yeah, that should be the same there. So let's just say this. Right, and then we just need to add those members to process. So we'll just put them somewhere, maybe here at the bottom. As alarm is false, and what's that, a keyword? This is a 64-bit integer for uptime counters, so that one was called alarm deadline, right? Okay, so I think maybe we can skip having the boolean. Actually, we can just say alarm deadline 0, and then because then we don't need that separate flag for that. So it simplifies things a little bit. And then what we want to do with this thing is that when we are in the scheduler, which is where we increment the uptime, we should probably let the current process finish what he's doing. So if he still has ticks left, we'll just let him finish. But the next time we get to the actual scheduler pick next, which is where we like look for anything that can be unblocked, and we process dead threads and whatever, and actually pick who's next to run. That's why it's called pick next. Maybe this should be broken up into multiple things actually. But next time we get here, we are going to look at processes that have an alarm pending. So here we are going through each process and checking if they're dead. So we could definitely do something different here if it's alive, and if it has an alarm. So alarm deadline is greater than, well, we'll say like if alarm deadline and alarm deadline is greater than G uptime. Or no, hold on, that's the other way around. G uptime is greater than. Okay. Then process send signal, sig alarm. And you don't need to know who sent that to you. It was the kernel, don't worry about it. Okay. Let's build everything. This code is a little wacky looking. But yeah, so we're iterating over all the processes and picking up the dead ones. It's kind of strange. I'm wondering if that should be like a separate iteration function or something, but it doesn't really matter here. Are we using that in a lot of places? Oh, it's only here. Process for each. Like that. Yeah, it's only here. Oh, I messed something up. Process.h 433. I don't know what I was trying to do here. Okay, oh, shit, I have to rebuild anyway. Well, since we have to rebuild anyway, I wanted to change this thing to use iteration decisions. So I'm just going to do that right away. So if we get abort and break, And then here we return iteration decision continue. And then we can do the same up here, iteration decision continue. And then we don't need to continue any processing. Like that, okay. Because then here, the thing is that, let's see, dispatch has unmasked process and signal. Right, yeah, so currently, I was just looking into this to remind myself. So currently the way that threads work, or signals and threads work, is that all the signals are always delivered to the main thread. And I don't actually know how that's supposed to work in POSIX. I haven't looked into it very deep. So that's something that I'm gonna have to figure out eventually. But right now, all signals just go to the main thread. So that's why here we can like iterate over threads and figure out, hey, do you have an unmasked pending signal? Whereas we're doing like process send signal, and it just sort of magically ends up on the main thread. And that's why. That's because, as you can see here, send signal actually calls main thread send signal. All right. Anyways, yeah, so the reason that I wanted to continue iterating here instead of continue processing is that if this process was dead, then we definitely don't want to do anything else here other than looking if it needs an automatic wait, or reap as it's called in the kernel. Reap is when like a process doesn't have a child or doesn't have a parent, then the kernel just takes care of destroying it. Normally, the parent has to wait for the child to be destroyed. Anyways, that's something entirely different. So yeah, then I guess we can just actually compile. Should have been doing that. And then we can see how well this works. We had 2-second wait, yeah. And let's just make sure we have the L test program. Let's give it a try. Come on, L. Ooh, shit, first try. First try, very nice. All right. Wow, that was it's a very small patch actually. Okay. So I guess we can probably try to do the return value as well. So let's see. Let's say alarm 3 signed. I don't know, ret, whatever, printf. No, alarm set is ret. Ret. Then we'll know what it says. Okay, and then let's see, user land. Did we rebuild? Yes, we did. Okay. Let's make sure we synchronize. And then I guess if we'll say let's see, unsigned previous or remaining on previous. Previous line remaining. Okay. And that would be if I'm on deadline 0 otherwise. I guess that's the wait, hold on. I'm confusing myself here, so let's just say it this way. If m alarm deadline and m alarm deadline is greater than uptime, then we still have a pending alarm. Otherwise, we'll just leave it at 0. We should make sure that we return it. Okay, and then we'll say previous alarm remaining is m alarm deadline minus g uptime divided by ticks per second. Okay. All right. Yeah, just need to compile the kernel, not the user line. Yeah, I guess that makes sense because we will have ticked a few times, so it's gonna not be exactly 3 seconds anymore. So there's still 2 seconds remaining. Let's just try it with 5. Make sure that it becomes 4, just to be sure. Oops, sync. Wait. I just changed this, not this. I'm stupid. This is a pretty useful API, because then you can sort of watchdog yourself against a stupid infinite loop like this one. Okay, so it's working. Cool. Let's do a patch review. Oh, wait, what was that thing here? Signal kernel send 14th L. Oh, look at that. Something here is not very good. See, we're just spamming the thing at that point. So when we actually do send the signal, we should be smart and unregister the alarm. So 0. And we don't spam it. Let's just make sure that that works. Should only get that one alarm. And we see only that one alarm and the process is dead. Cool. So now patch review. Okay, sys alarm. Previous alarm remaining is 0, but if there is an alarm deadline and it's in the future, then the previous alarm remaining is the alarm deadline minus the current uptime divided by ticks per second. Okay. And then if we are called with 0 seconds, then we turn off the alarm. And that looks a bit silly with that little space there, so then the alarm deadline is the current uptime plus the seconds times ticks per second. Cool. And then we just return whatever the previous alarm was, or how many seconds until. Cool. And then we have a 64-bit int, or 64-bit unsigned int actually for the deadline for the alarm clock. And here we are just changing process for each to use iteration decision to know whether or not to continue, instead of a bool, which was the old way I used to do things before I invented this beautiful concept. Okay. And then finally, in the scheduler, when we're looking at each process, then we check if there is an alarm deadline and the current uptime has passed the alarm deadline, then turn off the alarm and send the signal to the process. Cool. Let's commit. Kernel, implement the alarm syscall. And oh damn, I kind of like that little program, so I'm gonna commit it to userland. Add a this program for the alarm syscall. Nice. Okay, let's push that. And let's see it one more time. Flop. And you're dead. Cool, it works. That was straightforward, but still nice. So this is yet another POSIX feature implemented, hopefully correctly. So I think that's it for today's video. So if you made it this far, then I thank you for watching and for coming back and for hanging out with me while I hack. And I hope to see you next time.